All right, this is kind of a classic calc problem that we didn't really do much of. It's called rate in, rate out. You have some model of people or things entering and some model of them leaving, and you're going to then kind of, how many are there? It's entering minus leaving plus initial kind of thing. Anyway, the first step is to find e prime of 2. That's easy peasy, just set it equal. This is root 2, or sorry, root t is t to the half, so this would be t to the negative half, and then it's just power rule, and then you plug in 2. Then, more importantly though, is correct units, interpreting what that means in the context of the problem. So let me write out what I would say the cookie cutter for that. I'll write right here. So I would say at my time at t equals 2, what is t measured in? Hours since noon. So 2 hours since noon, or at 2, actually I would probably just say at 2 p.m., comma, and then here I would put in context the y variable is increasing, decreasing by something with units, by that rate, or at a rate of. Now this one's a little tricky because the y variable of E is the rate that fans enter. And so the rate that fans are entering is increasing or decreasing by this many fans per hour. And so, having said all of that, looking down here at the answers, and so this is just, they just rewrote this so that it's easy to do power rule. Then you plug in 2, you get a number, and then they said they put the at 2 hours here in the middle, but then this is the rate at which baseball fans are entering the stadium. That's just the y value of E. That's just what E of t is. It's the rate at which. So if it was the number of fans, then we'd say the number of fans is, but that's not what E is. E is the rate of entry. So the rate here is because that's the E variable. Over here, this rate, this y value, is decreasing, because it was negative, at this number, that, fans per hour. Wait, do they have 884? Oh, yeah. And they did 8 instead of 0.884 because this is in thousands of fans, because that's what it said earlier. And then fans per hour, because the rate is decreasing. So it's per hour. Okay. So letter B says when is a prime of t 0? Well, a prime is, I should probably look at it. At what time is a prime of t 0? A prime is the total number of people in attendance at the stadium at time t. Okay, well, the total number would be however many are there, plus however many are entering, minus however many are leaving. I don't actually know how many are there at this point. I do kind of in part C, but that's irrelevant because I just want to know when the change in the amount of people is 0. So at what point are the same number of people entering and leaving? Oh, okay. So what I could do is simply say a prime of t is 0 whenever E of t equals the other one, L of t. Whenever the entering and leaving are equal to each other, a prime is going to be 0. Because E and L are already rates, so I don't actually have to take the derivative of this. A is actually the integral of entry and the integral of L, leaving. Okay, so anyway, so that's all I'm solving. But they did it just setting it equal to 0, so you just minus the L of t over. So on the answer key, that's all they're doing. They're just taking, this is A of t here, this is A of t, and this is L of t. And we're just doing A minus L and saying it equal to 0. And so since this is a calculator problem, I would just graph all of that and graph 0, or I graph them and equal to each other, but you got two different answers. And all it said was find it, so those are your two answers done, 3 decimal places. Okay, letter C. At time 4, there are this many people. Write equation for the local linear approximation at that time, and then approximate something else. Oh, okay. So, L, let's switch colors. L of x is my initial amount plus my derivative. What is this? There are this many. Write equation for that. Oh, so it's going to be a prime of 4 and then x minus 4. And then the next part is I'm going to say a of, I don't have enough room. A of 4.25 is approximately L of 4.25. And I'm just going to plug 4.25 into that. So now the only unknown is how do I find a prime of 4? And that goes back to kind of what we just did down here. A prime of 4 is negative 3.541 because a prime of t is up here, is this thing. And so if I just plug in 4 into this, I'll get this. And since I already stored this as y1, I can just do y1 of 4. And then, yep, so this is the same equation we have. They just put this over here because point slope form. And then we just plug in 4.25, ta-da, and put it in the context. Okay. There you go. Hopefully that one made sense. And then related rates now, letter D. So when the player, so that's our freeze frame. Oh, wait, no, oops. Is 20 feet away from third base. So here's the dude right here. Hey, I'm running. And this distance here is 20. Okay, so let's call that, at what rate is the distance from home changing? So that would be this. Oh, so I just have a little right triangle here. So if I just draw this triangle out here, then let's call this x, y, and distance from home. I don't know why, that should probably be y and x, but whatever. And so then I'll have d squared is x squared plus y squared. And in my freeze frame, x is 20. And this y is always 90. That's not even a freeze frame. That's just a constant, actually. So I could do that. 90 squared. That doesn't change. Okay, but d changes. And so now I just take the derivative of both sides of that. And a player's running at a rate. Oh, we also know his rate. So we know dx dt is 20. And so now we're set up for Pythagorean theorem related rates. And then I can show you the rest of the work down there. They used the same thing but proper variables. Oh, yeah, very important. I didn't do the negative 20 because it's decreasing. His distance between him and the base is getting smaller, so it should be negative 20 there. And then they just worked that all out and wrote it out in the context. So hopefully that made sense.